you spent some time in Norwegian Island in complete darkness, and you did some research there.
Apart from not having the sun, which will over 45 days make you really want sunlight, but also in the Arctic, there are no trees.
So, could you tell us what is an aurora and what color is it and why?
Auroras come in many colors, but in Earth, because of the charged particles interacting with oxygen, you see green light predominant.
So, you told us that you're working on solar winds now and that you've also studied things about civilization collapse. Could these two things be connected in any way? Hello and welcome to Pulsar Talks, where we do short little talks with different researchers around the world. I'm Chase, and this is my co-host Ashkan. Ashkan, would you like to introduce our guest today?
Today's guest is Nithin Sivadas. He got his PhD at Boston University in electrical engineering with an expertise in space physics. And now he's a postdoc researcher at NASA working on solar winds. Welcome, Nithin.
Thank you, Ashkan and Chase. Nice to be in here.
I know that you spent some time in a Norwegian island in complete darkness, and you did some research there. Can you tell us a little bit about that experience?
Yeah. So basically, towards like the middle of my PhD, I got this opportunity to take a course in magnetospheric substorms in this university center in Svalbard. So Svalbard is an island in north of Norway, which is a Norwegian territory, but funnily it's actually international space. So anybody can go there without a visa. But you just have to transit through Norway, so you need a transit visa. But, because only ships and planes to that island are through Oslo and Tromsø. Either way, it's in the Arctic Circle, so half of the year it's complete darkness, and the other half of the year you have complete sunlight. And it was a perfect place to talk about the physics of the aurora, because you can see the aurora just outside. But it was an incredible experience where I met other scientists and like students who are now my good friends, and we stay in touch through the years.
Amazing. It must have been a magnificent experience.
Yeah, one thing that I noticed was that apart from not having the sun, which will over 45 days make you really want sunlight, and but also in the Arctic, there are no trees. That island had no trees. And so it was just these, desert-like landscape with the ice and snow and big mountains that just rise up above the sea. It's like almost like in science fiction. But I noticed that you also start earning to like wanting to see a tree, like any pattern that almost looks like a tree, like you really want to see it. And when I left the island, the first thing I did, like when I went to the Tromsø airport, was just go stick like glue onto the window, like the airport window, to just see a tree and like look for the sunlight.
So, could you tell us what is an aurora and what color is it and why?
Yeah, so aurora are lights in the sky that you observe in the northern and southern polar regions of the Earth. And it's actually something that you observe all through the solar system in many other planets like Jupiter, Saturn, and they're all produced by charged particles, so electrons and protons in and around the planet's magnetosphere, where within its magnetic fields. Those particles come down into the atmosphere, interact, and just like how you see fluorescence in your fluorescent lamp, those particles interact with the atmospheric gas and produce light. And so that's what an aurora is. And auroras come in many colors, but in Earth, because of the charged particles interacting with oxygen, you see green light predominant. And then you also see red aurora, you see blue aurora. Those are rarer to see. And there are other non-visible wavelengths like X-rays and UV that's emitted. And in fact, that was the kind of aurora that I was studying in my PhD.
Wow, so cool.
Yeah. So
yeah, it's fascinating because if you the funny thing that I realized was that the aurora that you see in photographs, right, are not exactly the same color, because photographs always have longer exposure, right? And when you go there and see with your own eyes, eyes have some limited amount of exposure. And each person will see aurora slightly differently. So the aurora is monochromatic light. Like it is, it's a frequency spectrum with very narrow band frequency. So the particular green that you see, depending on how much cones and rods we have in our eyes, we will see different shades. So when I look at the aurora, I see a grayish cyan. That's what I see. And I'm like, wait, this is nothing like in the photographs. Somebody's been cheating me.
Wow.
Yeah, this is a point that you only can hear from someone who's been in the field. From how I know you, I personally know you're my friend. I also know you have a lot of other interests, for example, in humanities. If you could also explain a little bit about that, how do you find time to navigate your other likings in other scientific or humanity areas?
Yeah, I think, in this sort of modern capitalistic society that we all live in, there's always a constant race, to develop your career and not just find sustenance, like to eat and like have a home or a shelter, but actually be successful in your career, whatever success means. So I like most of us notice this sort of race, and many of us feel like maybe we don't want to be part of it because we have other interests, right? We might care about music or arts or philosophy, right? And we want to do and experience all of these things. We want to travel, and we just don't want to be sucked into like a career that completely restricts us from doing any of these other things that are interesting. For me personally, I have become more and more interested in sociology, and but I'm also interested in history and philosophy and like how the world works and how societies work and power imbalances. And different political philosophy. But either way, all of these interests have sort of zoned in on me trying to work more seriously on understanding civilizational collapse. So I did a project a year ago with the Oxford Future of Humanity Institute to explore the statistical nature of historical civilizational collapse. And so how did I navigate this is that I made a conscious choice that there are going to be many career paths that I will consciously choose not to pursue because I would like to spend my time in these other things that I find valuable and interesting. So I think ultimately if people want to do all of that, they will have to make these choices given the kind of social system we are in.
So you told us that you're working on solar winds now, and that you've also studied things about civilization collapse. Could these two things be connected in any way?
That's a great question. I am no expert in civilization collapse. It's one of those areas that I'm venturing into. But solar winds, especially extreme solar winds that can happen, can cause effects in the ground, especially to electrical power grids. So this is an active area of study, and like for 1859, we had this ginormous solar storm called the Carrington event, where it was so big that people could see aurora in Brazil. Like the polar, the auroral region expanded so much because of the driving from the solar wind, and it also ended up melting transformers in Canada, and like in the United, even in Boston, had effects. So nowadays we are far more dependent on technology and electricity than 1859. So the effects can be quite catastrophic if some similar event happen. Our satellites will be down for a long time. Like, people lose them because there's no way to go up and like repair those satellites, and that would, can quickly stop credit card, like bank accounts. Banking can stop. Hospitals can stop functioning. So it can be a pandemic-like effect in a very short period of time. So I think there is danger to it, and there are countries like the United States, the UK, and all of that who prioritize studying space weather, especially because of this kind of potential effect on the economy.
So can you tell us what it is that you're working on now, and what are the possible applications of your current research?
So currently I am studying how the solar wind interacts with the Earth and how it affects currents in the ionosphere. Particular focus is the relationship between the atmospheric currents and the solar wind. So what I'm noticing is that relationship might be stronger than what we previously thought. And that result will have an effect in us understanding, how harmful big solar wind event will be to society.
So, Nithin, thanks so much for accepting to be our guest today. I really enjoyed this conversation. I'm sure a lot of the audience also have the same feeling. So thank you.
Yeah, thank you for having me.